Welcome to the first NINFA podcast. NINFA is a European project that started in 2022, and its name is Taking Action to Prevent and Mitigate Pollution of Groundwater Bodies. And the main goal of NINFA is to develop a decision support system that will be held into different parts, into different technologies. The first one would be the combination of advanced modeling and also risk assessment from different approaches with mathematical models, transport models, AI, and so on. Also projection climate scenarios in different case studies. We will also have novel sensors and monitoring strategy developing in the different demo sites. And finally, we are going to develop some novel and preventive treatments and trends of technologies which will be useful to mitigate pollution. This is a brief introduction of the project, and now I would like to go into detail with all the partners. We are 9 partners working in the project. CETRI, IMT, Deltares, Los Alcázares, Aqualia, University of La Sapienza, WINS, and WETSUS, and we are laid out as coordinators. And all of us are involved in the different work packages, and I would like to introduce all my colleagues and let them explain a little bit their work in NINFA. And the first one in the work package 1, I would like to introduce Eve. Could you please introduce the work package 1, the case studies, specifications, requirements, and knowledge gathering that you are performing in IMT, please?
Yes, thank you. So in the work package 1, the main objective are collection and compilation of the data of case study to form a knowledge base to be able to provide data for the other work package. We have also a task about the definition of the KPIs to evaluate the monitoring strategy for the work package 2, also the modeling, which is also included in work package 2, and water treatment technology in work package 3. And we need also to propose a strategy to validate the KPIs. We have also in this work package 1 an objective of developing a mapping of facilitator and barriers to NINFA solutions at each case study level. And we also have to conduct a survey to investigate the condition for answering the acceptability of wastewater reuse to citizens. And the result of this survey will serve as an input for the development of a social game for a mobile application for made in the work package 5.
So thank you. We should move into the work package 2 called Sensors, Monitoring, and Modeling. Please, Tom, introduce yourself.
Yes, hello, I'm Tom Sleutels from WETSUS, a water technology center based in the Netherlands. So we are the work package leader for work package 2, and that is indeed related to sensors, modeling and monitoring of data. So the idea is in the end to build a high resolution model to be able to track contaminants or saline intrusion in groundwater at a better resolution. Therefore we need data, so we develop sensors. We also use more standardized sensors, but we develop new sensors to be able to detect new contaminants. So that is one part of the job. We use these sensors in certain locations. We call them case studies in the Netherlands and Spain to monitor what is actually happening in groundwater flows. And we use this data as input for our models. And we have our specialist in modeling from the University of Sapienza here who will explain that a bit further.
Yes, thank you. I'm Marco Petita from Sapienza University of Rome, teaching hydrogeology, and I'm in charge in the work package 2 at NINFA for the modeling. And we are developing a modeling approach by using the standard protocols and the standard softwares related to groundwater flow and transport. Basically, we apply to two case studies. One is a region in Netherlands, another one is a region in Spain. And we work in a very close collaboration with partners of Deltares and of Wetsus, especially for the assessment of the modeling of the case study one. And case study one is related to a agricultural area, and basically the problem is that there is a shortening in water availability due to some climate change effect. And we are trying to simulate this and the effect on the transport of the contaminant into the groundwater system after this problem. The main findings indicate to us that we need to implement also the monitoring activity, and the results of the modeling can be used as output for the decision support system that will be described by the work package 5. We also are working in a strict relationship with people of the Deltares for the risk assessment. And the most exciting activity in NINFA was the relationship with the different land and the problems in Northern Europe and Southern Europe that are facing the same shortage in groundwater, but with different effects. And the close collaboration between all the partners are very useful for having some added value and to promote the final results of NINFA to be delivered to the general public and to be implemented in the decision support system for helping the people, helping also the decision maker to do the right things in front of this emergency.
Okay, thank you. Then we will jump into the work package 3 called Water Treatment Technologies, and I will be presenting. My name is Ainhoa Gaudes. I'm principal researcher at Leitat. And in that work package, we are developing different trends of technologies. We have 3 main tasks involved with different water sources. The first one, we are dealing with water runoff from case study in Spain, in Terrassa, in which we want to remove part of the contaminants, microplastics, hydrocarbons, and also we want to recover some heavy metals that can be present in runoff. So this would be like the urban environment. Then we also have another technology that we want to apply for wastewater treatment plants effluent, in which we want to remove part of the microplastics, but also the contaminants of emerging concern, and also have a deeper look into the resistant genes and bacteria. And we've been developing another technologies with activated carbon, sand filtration, and advanced oxidation processes. And in that, the intention of this technology is to be able to reuse this water for infiltration in the groundwater. Then we have another train of technology which is more related with the avoidance of nutrient leaching in the agricultural fields. We have a special case study in Los Alcázares in Spain, in which we have a huge nutrient load into the coastal lagoon of El Mar Menor. So we are developing a strategy of removing nutrients from groundwater with wood chip reactors, but also creating organic fertilizers and different amendments that could be helping to avoid this nitrate leaching into the lagoon. So all these technologies have been tested at lab scale, and we finally have another task in which we want to validate these technologies with real water. So we are now performing all those experiments with real water in the field. And this is the main challenge we've been facing, that it's the jump from the lab into the real water conditions. It's, as I said, challenging, but it's also very exciting, because then you realize how important it is to develop this kind of technologies. And that's all from my side. we would jump into the work package 4 for the risk assessment, please.
Yes, my name is Annemieke Marsman, and on behalf of Deltaris, I am the work package leader for work package 4, where we perform the risk and sustainability assessment. What we did in this work package, that we looked at climate changes and global changes and all the aspects that have impact on the groundwater quality. So we inventorized all these impacts and prioritized them. And in the next step, we also developed a risk assessment tool to define preventive barriers and recovery barriers on all these different aspects of the climate and global effects on groundwater quality. And we developed also a tool to do some quick risk assessments. And this is an AI model, and this AI model is based on the model that was developed in work package 2 for case study 1 in the Netherlands. And we developed a simplified model and trained this model to obtain data for an AI model. And with this AI model, it's very easy to calculate climate scenarios in a very quick way. So this risk assessment tool and the AI model will be on the decision platform so that people can use them and do some quick calculations. Thank you.
And finally, we have the work package 5, where the NINFA platform for development and validation, please.
Hello, my name is Panagiotis Vlachias. I'm Senior Solution Architect and owner of Wings FT Solutions. Wings is working on solutions software and hardware for vertical sectors. We're responsible for work package 5, that we are titled as NINFA Platform Development Validation. The NINFA platform is an integrated early warning issue support system for efficient holistic groundwater management protection. The NINFA platform leverages the WISense platform developed by Wings as a backbone, but integrates all the technologies developed in NINFA that were introduced before, the innovative groundwater monitoring and sensors, the hydrogeological and reactive transport models, the risk assessment tools, and the innovative technologies for pollutants removal and resource recovery. The first milestone that we built, it was important, was our first deliverable 5.1, in which all the partners of the NINFA platforms put significant efforts in order to combine the technologies under concise workflows that represent how these technologies can be combined together, provide a meaningful outcome to the user, either these users are utilities, policymakers, or the general public. The challenges that we faced are, among others, the integration of this plurality of technologies, the trade-off between the user requirements and the technical feasibility, because we try to do a good design of the decision support systems with the users, the testing and validations of the developed solutions in real operating conditions. Our next priority for the upcoming period is the delivery of the first official release at 31 of October 2025 and the second release at 28 of February 2026. And finally, we believe that these two deliveries will be very important since they will ensure that all the NINFA technologies, or at least part of them, will contribute to a platform that will be accessible by users trying to link these technology outcomes and the science behind them to real case studies, problems, and the users.
So thank you, all of you, to introduce your work packages and to give a brief overview of the NINFA project.